Good morning, everybody, and welcome to today's webinar. I'm Ben Thomas with UST Training. We do online ABC operator training, helping inspectors, operators, and service technicians basically be tank savvy, be the best they can be as a UST professional in the industry. And this is part of a ongoing series that UST Training provides to the public, providing free technical webinars for, like I said, operators, service technicians, and inspectors. And today I'm very excited to talk about a topic that when they wrote the federal rules back in 1988, fuel quality wasn't really kind of a big consideration, how fuel quality would affect operations and ultimately compliance of UST systems. And so I'm very excited to have Chris here today. Chris, your last name, please.
Last name is Biellier.
Chris Biellier with Seneca. And Chris is going to be giving a great presentation that I think will be particularly helpful, particularly for operators, because there is a kind of a lurking thing about fuel quality to have a direct effect on your operations, your bottom line, and ultimately UST compliance. So I think with that, I want to welcome everyone here today. I do want to mention the Q&A feature is on. So if you do have a technical question about for Chris or for me, type it up, and we'll try to answer questions as we go along, and we'll save a little bit of time at the end. But Chris, take it away. We won't believe what's inside your storage tank. Please tell us more.
Well, good afternoon, ladies and gentlemen. My name is Chris Biellier. It's probably morning for some of you and afternoon for others because you're being represented in different sides of the country. A little bit about myself. I've been in the general industry. I'm a professional geologist by education and licensing, but I've been in the industry, in the environmental industry, since about 1987. I've been in the petroleum-related industry for about 21 years now. I'm currently vice president of Seneca. I oversee a couple different divisions within our company. We are part of a larger group of companies under the OWL companies. Number about 12, 13 companies under a single banner. Seneca was the most recent group to be added into this group, and proud to be part of it. What kind of drove all this is this presentation in particular is a shortened version of about an hour and a half version that I do at different petroleum related shows, industry shows, and this is more of an informative way, and hopefully there's things in here that you'll relate to. Like many people in this industry, we got it started into it around 2013, 2014. We were reached out to by a large retailer, a customer of ours, and they were starting to exhibit a continuing a bucket of problems that were being associated with their fuel. And obviously, in the retail world, it's trying to make that there's a least amount of inconvenience to the customers as possible. And when they were having issues like slow flow or dispenser pumps shutting down or cars being stalled in their parking lot, due to water and fuel, or frankly, the biggest part was the cost that was being impacted by them as a business on repairs and continuous service calls to deal with issues that, unbeknownst to them at the time, was fuel quality related. So we were pretty much instructed that we need to try to figure this issue out and get into this service business to help correct some of the issues that were being experienced. Like anybody, we've been doing this for about 11 years now, and we had to learn through trial and error, and we had to align ourselves and learn the equipment, learn fuel chemistry to the best of our ability to look at each problem that was being experienced in the tanks individually and address those things. And since that time, we've taken ourselves to a national level to allow to address these issues with customers. And so what I'll do is I'll start up with the background of what we're going to be discussing today. So we're going to be going, about fuel quality or fuels, now versus then, examples of the types of fuel contamination, causes and effects. We're going to talk a little bit about storage and use because it's not just retail, it's commercial, it's backup and emergency generator industry. We've got private, we've got municipal, state, and federal institutions that are affected by this. Um, I won't get so much, I will not really be diving into anything like the aviation fuels. We'll try to stick to more of a gasoline and biodiesel, diesel topics. We'll talk about fuel analysis considerations, corrosion and bacteria issues that we're seeing in the field, the types of treatment alternatives and preventive maintenance alternatives that are out there. And we'll go a little bit about on the process description. Obviously, in my business, we build gas stations and service them and do everything else, but we also do a fuel restoration process that will be shared. So I'll try not to make this as any type of sales pitch, but more of an informative lunch and learn type of format. We'll talk about the different types of applications that are available in the industry to owners and users of fuels. And then we'll talk about those alternative tank methods. A lot of these pictures in here they're not stock photos. They're actual pictures that our people in the field have taken. So I'll try to point out certain pictures as we go through out here, so you can kind of do some matching with what's being described. So the bottom line is, what is fuel quality? Gasoline blends versus diesel blends. And the definition of fuel quality is essentially it depends on the type of fuel and its intended use. Gasoline will encompass factors such as your octane rating, sulfur content, the additives that are put in the fuels, any contaminants that can be detected and found, and cetane and ethanol content and density. Whereas diesel fuel is going to encompass things such as the cetane lubricity, the water content, sulfur content, additives, and stability. So any of the contaminants that are outside the spec of the fuel, can reduce the performance and the quality of the fuel because this is essential in operating our vehicles, our equipment, and our generators. We're seeing that today's fuels in particular are a lot different than 20 years ago. I had happened to sample a high sulfur diesel fuel that was retained on a river tugboat and had been in there for about 20 years. When we were surprised when we collected the sample and we submitted it to the fuels lab, that it was over 95% viable. It was still good fuel. And we will be talking a little bit about that sulfur side, that the effects of removing sulfur, from the fuel, good for the environment, but it also came with some new issues that we've had to address as the industry. So we'll talk a little bit about the causes of fuel quality issues. So the root causes that we're seeing that's being attributed to the fouling of tank components, to fuel quality, and the costly repairs. So back in 2012, there was a Biellier study done for the US EPA, and the petroleum industry, and the whole guide of this was to sample 42, 45 tanks across the country in different environments, different operating conditions, to look into why there was mild and moderate corrosion being experienced when we brought in the ethanol blended storage tanks and diesel tanks, and seeing the things that was being affected, like your dispensers, the components in the tanks. And there was an bacteria that was identified that was producing a vinegar-like acetic acid that was affecting the steel components, the metal components of the tanks. And to not go, you can Google this, you can look up the study itself. I think they're looking at, like, there's a third study underway, but I'll just kind of go over the takeaways. So the first takeaway was findings from the study that was revealing is that the corrosion was a lot more common than they had suspected. There's 35 out of 43 tanks that were sampled in the fuel and the water component bottom of the tanks and the steel around the tanks, where there was moderate to severe corrosion that was being noticed. The second takeaway was most of the owners were unaware that their tanks were affected. If you think about your dispenser at your fueling islands or at your business, those dispenser filters are there for a reason, to keep that material from that happens to be in the fuel from going into the vehicles or the equipment that's being dispensed into. A lot of times when it becomes over fouled, that dispenser will start to slow down, and it's becoming fouled due to whether it be debris, um, water, if it's a water detecting filter, or any type of foreign material that's in there that's affecting the pumps. It may not always be the fuel itself that's stopping the dispenser. It may be a foreign material, and you'll see some examples of this that was in the bottom of the tank that got brought up into the submersibles and stopped the equipment from operating properly. The third takeaway was that the corrosion wasn't just attributed to the steel tanks. It was being seen in the fiberglass tanks too. And of course, the fiberglass tanks being that there's hanging components within that tank that are being affected by those vapors that was creating the corrosion. The other takeaway was that exposed metal components were in the high portions of the tank, so in the ullage space. So that vapor that was in that 20% and greater space within the top of the tank was exhibiting the highest levels of corrosion. And the last takeaway is that this was the shocking one to a lot, is that ethanol was present in 90% of the diesel fuel samples that were collected. This was either in the fuel or in the water bottoms at the bottom of the tank or in the vapor gas. And so there was a suspicion that, is this happening? If it's not happening at the refining level or at the bulk plant level, the only other conclusion that was being read was it from switch loading, from transport vehicles that were going from hauling gasoline products, emptying, and then residuals still present when they were loading up with diesel fuel to bring out to the end locations.
So, Chris, not even diesel is really safe from ethanol contamination. I mean, so it's suspicion that the ethanol is kind of piggybacking on a diesel load from a tanker that used to contain gasoline. So is that
Yes.
wow,
Yes. I
wow.
mean, the bacteria and stuff gasoline contains bacteria too, but it's not prevalent. We don't see the prevalence and the effects of bacteria mass. But ethanol by itself is not corrosive, but it becomes a problem when it's mixed. If there's microbes present, in the diesel fuel, so
Okay.
it helps accelerate that. Obviously, what we're going to really stress here today: water. Water is the catalyst. Water is the catalyst that creates all problems. If you don't have water in your fuel, you don't have an environment in which microorganisms, bacteria can exist. But all fuel has some form of moisture in it, and in our today's fuels, they can take on a lot more moisture content with the removal of sulfur and the addition of biodiesel fuels in the industry. There's certain states that are starting to really look at any water in a tank has to be removed. And by the US EPA's study, they determined that you only need about a quarter of an inch of water, that free water that's fallen out in the bottom of the tank, to create an environment in which those microorganisms will flourish. And then you'll hear a term called micro-induced corrosion, MIC, which that those carcasses and stuff is creating an environment that's corrosive to the steel components of the tank. Obviously, time. The fuels today, back in the 60s and early 70s, the government, the Army had said that their fuels were lasting 3 to 5 years before there was any noticeable change in their fuels. But I don't know how really deeply they dived into it. But today's fuels, really only have a shelf. Diesel fuel in particular has a shelf life of 6 to 12 months before it starts taking on some quality effects that will affect the fuel. We're seeing this a lot more, not so much the life of the fuel as far as its original specs are concerned on the retail side, because they're constantly changing their fuel out. In some cases, many times a day, depending on the size of the retailer. But where we're really starting to see issues is on the backup generator and emergency storage bulk tanks that are used to run the generators at hospitals, municipalities, data centers, banking institutions, um, where that fuel is sitting in there for a long period of time. And a lot of times, if you remember back when Hurricane Sandy hit the East Coast years ago, 85%, or depending on the source you get with, most of the majority of the breakdowns in the generators was not human related. It was fuel quality related.
Hmm.
The generators started, and then they broke down. It was due to fuel quality. There was material that was in these long 15 years of storage of fuel in these tanks, and they weren't keeping a good eye on it. I cannot stress enough to constantly check the condition of your fuel in your tank as much as you're able to, whether that be through a visual assessment or through a laboratory analysis to determine if that fuel is meeting the spec for the equipment that you're using. I mean, today's, is particular in the diesel truck industry and the heavy equipment industry, the tolerances are so tight now that even the dispenser filters that we have on the dispensing equipment isn't tight enough to keep micro materials from getting into your fuel filters. I have a big 3/4 ton diesel fuel truck, and I have to I change my fuel filters, my two fuel filters on my diesel pickup truck every two oil changes, and it's expensive.
Wow. Wow.
Um, and I've even, after two fill ups, my got an alert on my truck saying that my fuel filter is failing. And so, that tells me, where did I get the fuel from? Am I putting additives in my fuel when I fill up to help disperse these things so it's doesn't affect my vehicle as much? So that's time. Temperature effects. We've got different environments. We see different conditions in tanks, whether it be in Texas or whether it be in Michigan. A lot of it is temperature related, climate. You've got vents on your systems, and it's pulling in moisture, and that moisture will accumulate relatively quickly if unchecked. Other things that we're seeing is rain events, and some portions in the southern coast are affected more so with high water table conditions, ingresses into the tanks, and water is getting in there artificially, and it's affecting the system. And then obviously oxidation will affect this. These particular sample pictures in front here is materials that we pulled out of a tank. And these pictures will show up in other slides, and they'll have a description next to them. So examples of contamination, obviously water. We're seeing in our fuel quality, in our service that we're doing for customers, we're seeing about, depending on the time of year, it's usually 75% diesel tanks are being addressed, and 25% on the gasoline side. In the summer months, we're seeing as much as 50-50 on the split between the two. Phase separation is a term you're going to be here. Probably most of you have already heard of it. It represents about less than 5% of the incidents that we address. But in certain parts of the country, in the South, the Gulf Coast region, it's more prevalent. Inorganic debris, sediment, sand, rust. We see a lot of rust and metal particulates in tanks. If that's a steel tank, then that should raise a flag. That's a part of that tank the thickness of that tank is being affected, and you're risking a chance of either a catastrophic or a gradual release of products into the environment if that tank becomes compromised. We have seen.
Chris, how is sediment and sand getting into a tank? That kind of boggles my mind.
We've seen sometimes during installation of the tanks,
Okay.
where when the above pipes are being installed, care is not always being taken to ensure that sand and material is not being introduced into the tank during the installation phase, and it's not being addressed till sometime later. Sometimes in some of these dusty environments where the vents aren't adequate, and airborne dust is getting into the tank, and we also see some sediment that's being delivered also in the from the fuel delivery system, from tankers, bulk deliveries. A lot of it is speculative. Sometimes it's been determined it occurred after a fuel drop. There's always in this industry, there's always a lot of finger pointing, well, it came from the terminal or it came from the refinery. The end result is that the end user, the retailer, the commercial user that has the tanks, usually is left up to prove that point. And that leads to costly events where they have to address the issue that's going experienced in their tanks. Uh, we'll see a lot of, in the fuel degradation part, a lot of byproducts. We see a lot of, in these pictures, this third row down, that's the slime and the dead bacteria carcasses that we're seeing. And we'll talk about the bacteria effects in tanks. Now, the upper right there was a recent service we did for a retailer, and the fuel restoration unit we were using to rehabilitate the fuel, the pump stopped. We couldn't figure out what was going on, and the technician had to take apart the hose, and stuck in the hose was a dead mouse. That was from sweeping the bottom of the tank. There was a mouse. We've removed things such as ratchet straps, string, gloves, the diapers that you used to sop up spills. There'll be pictures of that in here. We've pulled a lot of different things out of the tank. And kind of the misunderstanding in the industry, a lot of people, when I get a call, they'll say, I've got algae in my tanks. Well, it's not algae. Algae requires sunlight. It's the bacteria, the molds, and the fungi that are growing in the bottom of the tanks or the fuel system, and it creates gums, varnishes. We're seeing a lot of dropout of the materials that's within the fuel when fuel is sitting for a long period of time. We see things such as asphaltenes and tars dropping out into the bottom of the delivery system in generators in particular, those gums, and then that will affect the injectors and the motors, and then a very costly repair. Here's some examples. It's the fuel quality is not affected on the type of fuel. We've seen it in racing fuel. We've seen it in obviously in ultra low sulfur diesel, ethanol, non-ethanol gasoline blends, off-road, on-road diesel, and E85 tanks as well. Low sulfur. So since around 2006, when the industry changed the fuel requirements to only allow 15 parts per billion, now that, is that going to come down? Obviously in the regulatory industry, as these things are being more and more addressed and understood, we have to look at how's the fuel quality being affected by it. I mean, obviously, when ethanol was introduced and biodiesel and ultra low sulfur diesel as a major component, obviously that was better for the environment. But with that, we had to add additives. The distillation process of creating these fuels is different, and there's some backside handicaps that's affected by it that we have to address. We weren't seeing this, in the 2000s and up until 2006. We weren't seeing the conditions we're seeing today, and that's attributed to the removal of the sulfur from the fuel. Obviously, sulfur, you want to look at it as like a flu shot. The sulfur is poison, and the microbes couldn't exist with the presence of that sulfur. Sulfur dissolves and carries the water out of the fuel systems, and a high sulfur diesel could dissolve and carry a higher percentage of parts per million of water. The ultra low sulfur diesel, in contrast, it carries 50 parts per billion of parts per million of water at 50 degrees and 200 parts per million at 100 degrees. So this translates to about 1.7 ounces of water per 100 gallons of fuel. And this source was from the Bell Performance Lab study that was done. This results in, more water settling to the bottom of the diesel fuel storage tanks as it can't hold on to that. So that same amount of moisture being produced in fuel tanks via condensation, the heating and cooling, the weather patterns we're seeing in our where we respectively are living and doing business, these thermal changes in humidity affects the tanks. And ultra low sulfur diesel, predominantly 60% more water in fuel tanks than the high sulfur diesel did. The other component is that we talk about is biodiesel. Biodiesel blends mixed with regular ultra low sulfur diesel will contain a higher level of water.
Hmm.
But at the end of the day, water is the catalyst because this will sustain an unhealthy tank.
And so sulfur is kind of a double-edged sword. I mean, it kills the bacteria, but it also strips water out. That's an interesting
Right.
conundrum.
You're right. Right. I mean, we've got better, lubricity now, but we're having to put a lot more additives, into the fuels. I mean, there's a chemistry within chemistry in the petroleum products that we're using today, and a lot of people think that, well, it's a one and done deal, and then that's not the case. Things such as biocides and additives that are put into tanks, they don't last indefinitely.
Hmm.
They start to degrade themselves, and you've got to check that. So I always recommend periodically, check the chemistry of your tank. Is it within the specs that you're selling? Um, we often see a lot of incorrect automatic tank gauge readings in tanks. Will be called out that there's water in the tank and the float on the ATGs being pushed up when actually there was very little water, but it was predominantly a mass of biomass and material in the bottom of the tank that was actually pushing up that float and giving a false reading. Um, and we've also seen that material can also affect that float from operating properly and locking it in place. We'd also see a lot of malfunctioning in the seals and gaskets and valves due to this buildup. We have to look at, we don't want to be treating just the effect of it. We want to look, all right, what caused this problem? And we start to investigate. We pull the submersibles out. We'll open up the dispenser and unscrew that dispenser filter and open it up and see what is the problems causing it. And obviously, on the pictures on the bottom here were foreign materials, rags. We see that sometimes the delivery drivers will lose their end caps of their hoses, and so as a quick fix, they'll shove a rag in the end of it so that droplets of fuel aren't dropping out into their onto the ground or on their truck beds. But they'll forget that rag is in there when they go to deliver that bulk fuel to that final destination, and it gets blown off from the bottom of the tanks. And these are kind of the results of that. These are the things that we've removed during restoring fuel. Root cause affected, from fouling tank components, the inorganic, foreign material and debris, the microbial influence corrosion. We're seeing a lot of corrosion when people are switching to a higher blend of ethanol graded fuel from an E10 to an E15 or from a non-ethanol tank to an ethanol blended fuel. Here's some examples of those blockage. Those rags there was what was pulled out of the bottom of a fuel tank.
Wow.
And obviously it slows our process down because we have to shut down this pump motor here. This was a foreign material that we had to get it ran off to a lab, and it was something that was a contaminant that was somehow introduced into the delivery driver's bulk truck, and we ended up having it took about 3 days to correct this problem in this tank. It was a one-time thing, but it was very costly for the customer. And these are examples at the end of each project. We take a picture of the material removed from the tanks so that there's a documentation. It can be big pieces of metal. We've seen a tremendous amount of sand and a lot of rust and gravel. But this was and it's mixed in with the bacteria mass that's being removed as well. But this should be an alert to the tank owner that if this wasn't introduced from a delivery, then it's coming from the components or my tank itself. Sometimes we'll see a large amount of metallic material being removed that will recommend to the customer get a tank tightness test to ensure that tank is not leaking because the thickness of that storage vessel is compromised in some way. When you're looking at the cause of the issues in the fuel, that's contributing to your mechanical breakdowns, look into it. What is causing my problem? This particular material, back in the early days when biodiesel was being introduced into the industry, we were seeing that the storage of these bulk fuels was being directly affected by cold temperatures. There was the quality control of biodiesel in the beginning was not as good as it is today, and we were seeing things such as glycerin fall out. And when glycerin was falling out of the fuel, it was not going back up into the column of fuel. Once it falls out, it fell out. This was being delivered to some sites and was creating these issues. We also seen things such as incompatibility within older fiberglass storage tanks that were not compatible with the ethanol blended fuels. And we were seeing things such as the fiberglass resin glues within the skins of the fiberglass tanks were being compromised, and also kind of being very rubbery and breaking away from the skin of the tank, and was creating the problem. It was a sticky glue substance, and it was creating a lot of issues. So obviously, if you're going to switch types of fuels or different percentages of different types of fuels, make sure that your fuel delivery system, as well as your tank and your components, are compatible with that fuel. Back around 2018, in the Midwest in particular, we seen during the winter month, it was a drastic shutdown of a number of retailers within a certain region, but particularly in Iowa, some in Wisconsin, some in Illinois. And we found it was a drag reducing agent. A drag reducing agent is a 5 part per million delivered additive that's put into the delivery systems in the pipelines to help minimize the friction loss of that product being delivered down the line. Mm. If that was tested in a lab, it tests within specs. If you took in a sample that had drag reducing agent in it or found, it would pass the fuel spec analysis. The problem is that we were seeing, and we were kind of correlating with temperatures, that when the temperatures were dropping and when the fuel was picked up at the terminals and additives were put into the fuel for delivery to the retail sites, it's driving down the highway. It's 10 below zero. The temperature that fuel being delivered was much colder than anticipated, and then it was being delivered into underground storage tanks that had an excessive ullage space. They may have only had 20-30% of the fuel capacity of the tank filled, and we were seeing temperatures of around 37-38 degrees of the fuel, and the dispensers were automatically shutting down. We'd pull a sample and it looked like good fuel, but we would do what was called a pencil test, and we would take a sample and just take a regular leaded pencil and dip it down into the jar of the fuel, and we'd pull that stick or that pencil up, and it would drip, very similar looking to egg whites. It was a clear fluid, but had the viscosity of like a white egg yolk. And when that would hit that dispenser filter, it would instantly clog it up and shut that dispenser down. There are, reportedly there's some dispersants out there that can be added fuel to help break this down. But what we were seeing is that once that fuel regained a certain temperature, and I'm not a fuel chemist, but these were the things that we were correlating, that as that temperature raised within that tank environment, that fuel, the problem went away. What we were having to do is literally take a fuel polishing truck to try to remove this stuff as much as possible from the bottom of the tank system, to remove as much of that separated drag reducing agent as possible. We're seeing this pop up from time to time, but it definitely, if you see things like this, take a sample, send it to the lab, and get it analyzed. Water is the root cause. We talk about this, throughout this presentation. Is it in the delivery of the instant? It's an instant notice when it's delivered. We've seen a fuel drop taking place, and then instantly those pumps are shutting down, or there's cars shutting down in the parking lot. A couple of years ago, I think it was $15,000 to $20,000 per claim for every vehicle that went down in a retail parking lot due to water in the fuel. Um, is there is the spill buckets? I've seen where the spill buckets, somebody's pushing the plunger down to empty that spill bucket, and there's water in that spill bucket. Not having your riser caps replaced, during a rain event that's left off, and we see catastrophic events where water is entering the tank. Slow could be a slow groundwater issue entering the tank. The outside pressure is greater than on the inside of the tank, and it's squirting water inside that tank. Obviously, you've got tank gauges to help detect water, but sometimes it's they're not operating properly. They're not detecting the water, and it's too late. And then obviously condensation and water from humidity and things like that, because tanks will sweat just like we do as humans. Diesel fuel and water is a bad combination. It's a petri dish. Essentially, when you got how this functions is the bacteria is not in that fuel. That bacteria is going to be at that interface of where the fuel and water meet, and that bacteria is going to actively eat that fuel. That the fuel is the food source. The water is the environment that microbe requires in order to survive. As that microbe is eating that diesel fuel, it dies, and that carcass drops to the bottom of the tank. What we also see is that people will inadvertently bioshock their tanks with biocide incorrectly. They'll when you have to add biocide to a tank, just imagine that your fuel levels go up and down in your tank. As that fuel level is rising up and carrying contaminants, as that fuel drops, it's sticking to the side of the tanks and not just the bottom. So we want to make sure that when we do a biocide into a diesel tank in particular, that we have that tank as full as possible. So you allow that contact time of that biocide to be touching those sides of that tank and the entirety of the fuel, and also the bottom where it's going to be accumulating. You will see bacteria start to drop out after the biocide is introduced into the tank, and you want to make sure you have plenty enough time of contact time. It's not add the biocide and start removing it. You want to make sure there's a minimum of 48 to 72 hours of contact time after you put that biocide in. And you may see some slowdown in your pumps because it's dropping that bacteria out. Phase separation, with the introduction of ethanol into the fuel industry, we've in different states, we've got E10 or E15. Certain states, like with Iowa, if you're selling E10, you can have up to 10%. You may have 2%, 4% in there, but that's allowable ethanol content. Whereas you may have states like Missouri in particular in the past, where if you're selling an E10 fuel, you're only allowed a variance of 0.5%. So if you've got 9% ethanol and you're selling E10, that fuel is out of spec. And the same if it's greater than 10.5. What happens when water is introduced or enters an ethanol blended tank? That ethanol will grab on to the water, or the water will grab onto the ethanol molecule and drop it to the bottom of the tank. In ethanol in particular, it's only 3.8 teaspoons of water per gallon of E10 that can lead to a phase separation. This is according to the EPA. So it's only like 0.5% at 60 degrees. Once that water grabs onto that ethanol and takes it down to the bottom of the tank, you'll have an alcohol water layer at the bottom. And then over time, if you let it sit long enough, because water is just slightly heavier than alcohol, that water layer will develop on the bottom. Now, even when you remove the water and that alcohol water content, whether you're using a vac truck like we use, your fuel is still out of spec. It's not an ethanol fuel. That ethanol has been pulled out of that fuel. So you're going to need to do your calculations to add ethanol to that fuel to bring that back up into the proper spec. There are additives out there that if you have a small amount of water, that can put that alcohol water back into suspension so that it could be safely burned. But there are instances where you have a catastrophic water event in a tank that you just have way too much water. And sometimes the fuel, you have to weigh the benefits of trying to restore the fuel, or is it easier just to remove the entire contents and dispose of it? And obviously that can become expensive because you've lost the sale of that product. You had to pay for that product to deliver it. Now you got to pay for it to be disposed of, and now you got to pay for it to be replaced. So make sure you know your options. These are examples of before and after of tanks that were in phase separation and corrected. This is an example of water in a 40 gallons of water in a 10,000 gallon E10 tank. And something to consider, in an E15, they can absorb, E15 tank can absorb about twice the amount of water that an E10 tank can. We don't see phase separation really in E85 tanks because there's so much alcohol content, it's grabbing onto it and it's holding onto it, not dropping it. So some of the costly effects. This particular site right here is only 7 months old. The top row of pictures was a 7-month-old site that had very, very severe corrosion effects from an ethanol blended tank, ethanol in a diesel fuel tank. And it wasn't checked. And they had failures and they had to be corrected, and it was expensive. So you have to, could half an approach be 100% mistake? And the answer is yes. These are the things you want to avoid. If you're seeing issues in either in the delivery system, in your fuel, you're seeing things that the fuel doesn't look right, doesn't smell right. There's sediments or particulates that you're noticing in the samples you're collecting. Look into it, especially in the emergency backup systems, your generators. We've got hundreds of thousands of backup generator systems, across the country, whether they're in hospitals, whether in data centers, whether they're in homes, whether they're in schools. You don't really see the problems until there's a catastrophic event where the main power fails and you're relying on backup systems. Don't ever think that a little water is not that big of a deal. I'm sorry, you got a question?
Oh no, I'm yeah. So many tanks I'm aware of are subject to having X amount of water in them. I mean, even the national API standards. I don't know what they are today. They used to say between a ½ inch and 2 inches. You might want to do something about it, but I think those standards have been amended. But yeah, a little water can do a lot of damage.
Well, and years ago, to your point, you could have 2 inches of water in a high sulfur diesel tank. You didn't have bacteria, and the draw for the fuel was 6 inches off the bottom, and it wasn't drawing in any water. The water wasn't noticed until it got a higher accumulation. But in the older fuel, you could have the water would drop straight to the bottom. Yeah. Now, because of fuels, the water is being absorbed and then it's falling out. If you've identified, usually if it looks like bacteria or a microbial type contamination, the laboratory will pretty much confirm it is. Sometimes you think it's bacteria and it's actually a foreign introduced contaminant that doesn't align with that. But if you do have microbes, bacteria that's being detected in your tanks, address it. That means you've probably got a water issue or you had a water issue, and it's not going to go away. It's going to continually doubling in size because that fuel is there to feed it, and that water is there for it to flourish in. Polishing or cleaning your tank, whether mechanically or taking out of service and entering it and cleaning it, and using chemicals as a additive to help keep it at bay. So I say like a flu shot. Once you clean your tank, make sure you have your additives in place to keep it from taking place. If you start out with a base clean tank and you've got a biocide type of regimen to your preventive maintenance program, that bacteria won't exist as long as you've got the correct additives in there. But keep in mind that biocide is not indefinite. It may only be a number of weeks. It may be a couple of months. So as your fuel is being removed and used and you're getting replenished it's constantly getting diluted. So you want to have a program that makes sure you get it in place.
Chris, we did have a question. A Colorado operator, they're fairly new tanks, already had diesel tank problems. I had to add biocide due to icky growth. The question is, we were told to add biocide to a low tank, meaning I think a low empty tank, and add fuel on top, then leave to sit before dispensing. Is this the correct procedure? In other words, low,
So
add
so the
biocide, fill up tank, wait.
where I've seen people make the mistake is that they will pour the biocide, uh, unconnected to a delivery. Let's say you've got a 10,000 gallon tank that's got 8,000 gallons of fuel in it. You go out and buy biocide, you get it from a distributor or whatever, pouring it down the drop tube, the fill tube that goes down to the bottom of the tank is not recommended, because then that is just basically dispersed on the bottom. I always recommend you introduce the biocide during the delivery of the fuel so that you're getting a splash effect. So in the case of the question that was asked, the tank was low, add the biocide, then you had a delivery. That's pretty much that's the same effect. You're helping using the turbulence of the fuel delivery to help disperse the biocide throughout the tank system. My earlier point of only treating a partially filled tank is that you're not touching the sides of the tank that may have active or living bacteria that's not being touched by the flu shot.
Hmm.
This was a particular event where there was a breakdown. I believe this one was a fiberglass tank. This was a major failure within the delivery system. Pulled the components out, pulled samples, sent it off. This was sent to Dallas laboratories, and the results were it indicated there was a copolymer of polypropylene that was in the fuel. Now, whether or not this was part of the tank system or delivered in the fuel, that was not assessed. But this was a major incompatibility issue. The process. So if you have what's called a fuel thief, and the old term is bacon bomb, and it's probably not a good term to use this day and age, but when you're pulling a sample from your tank, do not pull from the drop tube area where your fuel is being delivered. That's going to be your less impacted area, because if you just picture fuel being delivered into a fuel system, if there's material at the bottom of that tank, it's being pushed to the ends of the tank. I always recommend pull that ATG out, or the location to the bottom of the tank that's going to be closest to the suction delivery portion of the tank, and pull a sample from that point. And you'll see, I've had customers that have said, "Oh, I pulled samples from my drop tube where the fuel's put in, and they're always clean." Well, yes. Have you pulled it from where your ATG is? Because I guarantee you're probably going to see a difference in the results. So if you can do it, if you can collect from the ATG, or if you've got having to pull the submersible out for whatever reason for maintenance, pull a sample. If there's bacteria that's confirmed or suspected, treat it. Allow it to. Now, some people will add the biocide and then not address the mass of the material. There are dispersants out there that help kind of break it up, but it just doesn't just vanish and go away. You need to address it. Obviously, public perception is very important to people, that if you've got a delivery system that's pumping very slow or it's shut down, that's an inconvenience to the person that's fueling up, and they may not come back and use you as a customer anymore. So determine the effects and the impact of your business. And in the commercial industry, it's going to be a little different with people that have heavy equipment. Affects their maintenance and their equipment costs. And their efficiency in their business. This is just an example of a fuel restoration system. Most of the industry out there, there's going to be common components. There's going to be a gross size material, such as a catch delivery system on the front end system part of it, such as a basket strainer. that usually strains down to about 1/8 of an inch size of material. Then the fuel will go to a bag filter. They can go down to 1-2 microns, and then it'll go to a water coalescer. So it'll spin out any suspended water droplets within that fuel and collect it where it can be drained off, and then it'll finish with I call it it's a dispenser cartridge on steroids. It's 18 to 24 inches in length, and that's used as kind of a polisher. There's also portable systems that are on carts, and there's systems that are on trucks. We did have to, because of the generator uptick requests. A lot of these generators are in hard to get to areas. You can't drive to them. Sometimes they're on roofs. Sometimes they're in basements. Sometimes they're in corridors in the bottom of hospital basements. These are usually fed by a bulk system externally to a day tank. And usually we're either cleaning the bulk system outside in the top right, or we're cleaning the day tank down in the basement area.
Chris, I did have a question. This is an interesting question. What are your thoughts on a continuous in-tank filtration system? After this talk, I'm imagining everyone's going to run out and try to come up with some sort of cleaning solution. Are there in-tank continuous filtration equipments, and what do you think about them?
There are, and my personal opinion is not always going to be the same as those that are selling that system. There is benefits to them. I mean, obviously, if you can continually touch the fuel that's within the system with a passive, I call it passive. It's less than a gallon per minute processing, and usually depending on where the draw tube is. We do see in generator systems where you have multiple ballast walls within the container that is preventing any material from reaching where it's being drawn from. Also, if there's not enough turbulence within the fuel, you're only addressing what that system is touching. I do see systems that have worked, but it's usually on the smaller side. The smaller fuel storage systems, because there's less of a square footage area of fuel that has to travel. The bigger the tank system, unless that removal system that's taking the product out of the tank can get to the ends of the tanks or allow that fuel to circulate throughout that tank, it's going to be difficult. Because just like if you're panning for gold, and if you watch the gold rush, when they pan for gold, that gold is heavier and they're swishing it around, and if it's not swished around enough, that mud and dirt will settle and stick in place. Kind of along the same analogy. I'm not here to say one system is better than the other. Obviously, it's the results that tell the story.
Okay. It sounds less viable for a large, busy site, though.
Yeah, unless you've got a system that's crawling along the bottom of that entire tank system, it's very difficult to address that. So you want to be able to move that product as much as possible, or get the material dislodged so that you can remove it effectively. And obviously, we clean to a clear an ASTM opacity clarity standard. We don't stop polishing until we get clarity, and then we confirm that with analysis if required. These are before and after. This is just examples of before and after from a fuel polishing event. The samples that on the left of each picture were drawn from the ATG ports, which usually shocks people because I'm not seeing it come out the end of my dispenser nozzle. Well, it's because you got a dispenser filter there that's helping block that. Mm-hmm. But also, are you having to change your filters or your dispensers all the time at $20 a piece for the dispenser, and the cost of the technician to change it, and the public perception that pump is down? And these are just examples of the before and afters. Different types, from E85 to diesel to E15, E10, E10 ethanol, and biodiesel. A key point here: all fuel types can be affected, and the components can be affected, and the tanks are susceptible to this degradation due to the corrosive nature and for the catalyst of water being present. This is just some more examples of before and after. That bottom right-hand picture was 60 pounds of metal flakes and particulate that was removed from a tank in one clean. If you do have a company that does fuel restoration, make sure you're getting some type of a service report. What they did, what the before, what the after. Sometimes you're dealing with a legal claim that the fuel quality was in question at the event time. Make sure you've got all your I's dotted and T's crossed. What was the water content in the tank to start? What was it at the end? Pull those ATG strips and see what the volume of the tank was at start. There's some that in our particular process, you can continue to dispense fuel while we're doing the process, so there's no disruption in business. There's other ones out there that require the fuel system to be shut down completely in order to do the fuel polishing. There's some idle differences between different technologies out there and how fuel is removed and polished and restored. And that varies from different parts of the country, different climates, and different types of scenarios, whether it's retail, commercial, bulk, or genset. So there's three primary options, and we've done all three of these, but they all have benefits, pros and cons. Manned entry of the underground storage tanks is going to be your most expensive. You got to shut the system down. It's going to be the longest downtime, and it poses the highest safety risk because you're having a professional or employee of this type of service go into the tank and physically clean the tank. So all the contents are removed from the tank. You've got OSHA safety considerations because it is confined space. And obviously, if it's a gasoline tank, there's different safety considerations to consider, and usually you're not performing a manned entry in a flammable environment. Sometimes the fuel is removed from the tank and stored on a tanker so that the inside of the tank can either be addressed. Sometimes the tanks are being cleaned for inspection purposes so that their internal repairs can be made. But this is going to be the most expensive method used. Sometimes it's can't be prevented because there's other mechanical issues inside the tank that have to be addressed, so it requires a manned entry. But if you're using it to remove the bacteria and stuff, it could be your most effective because you are actually addressing every surface area of that tank, but it comes at a cost.
I do want to point out it is the top of the hour. I said we'd go an hour.
Yep.
I think we're in the home stretch here.
We're down to the last two slides.
All right. Thanks, Chris.
The second is the second most expensive, the moderate downtime. That's a non-entry cleaning, where you're essentially cleaning the tank without physically entering it, either using the sometimes the diesel fuel product as a cleaning mechanism itself through like a 3D nozzle mechanism, and using that fuel to clean the tank. It also requires the tank system to be shut down, and can have some time affected by it to get the tank clean. And sometimes transporting the fuel offsite or refuel polishing it when it's delivered back into the tank. And the least expensive, in my view, is just the fuel restoration process, where you're introducing a vacuum nozzle into the tank bottom, sweeping the bottom of the tank, going from tank end to tank end, and then as you're processing the fuel, you're filtering it down to a spec level of a 1 to 2 micron, removing the water, removing the sediment and bacteria, and reintroducing into the tank. And in our cases, you can continue to operate while this is being done. And I thank you very much for your time. If anybody has any questions, arguments, disagreements, I fully expect that. I mean, this is just from my perspective of my 11 years in this, but you can reach out to me via email, reach out to me by my cell number, or you can reach out to our companies directly.
I did want to point out, Chris, one thing that really struck me about this presentation is that, like, a diesel tank is not just a diesel tank. A gas tank is not just a gas tank. I mean, there's a whole ecosystem of things going on in there, both organic and inorganic. Just that visual alone is really helpful. Are there sites out there that for which this is a non-issue? In other words, is fuel quality like something everyone should be watching for? There's certain I know you talked about like emergency generator tanks, biodiesel tanks. Are there sites out there that kind of that this is not a problem, or is this kind of a universal problem with tanks?
Those that start out in the beginning with clean fuel and keep up on a preventive maintenance,
Okay.
regimen, either by additives or making sure they're keeping an eye on their fuel, checking their fuel, taking samples periodically, doing quality control analysis as they need to. And then if they do see something, they're addressing it right then. A lot of times, a lot of people are reactive. They're not addressing it until there's obvious conditions that they didn't know about, such as a pump shut down or something failed due to a clog or material that wasn't known to be in there. So everybody's susceptible. It just depends at what degree, depending on how it's addressed and how they're keeping on top of it.
Should everyone be getting a baseline fuel quality assessment of their site versus like waiting for, the car to stall down the street kind of thing like that? Or
We found that it'd be less uh, financially impactful to address it if you do a baseline sampling of all your tanks. And if it looks like it's going towards that path of it's going to create a problem, address it at that time. Waiting for it to shut everything down, now you've got more expense on your side, on the back side of it, loss of a fuel cell, cost of repairs, of something mechanical in the system when it could have been addressed on the front end. I always recommend if you have water, address the water, even if it's a small amount.
okay.
Bacteria grows at a really high, fast rate that people may not be aware of, and it's going to continue to duplicate itself if not addressed.
Chris, thank you so much. This was super informative. Hopefully, everyone here got something out of it today. And Chris, you and I will both be at our respective company booths at the PEI show in Chicago this October, right? Any other conferences or conventions you'll be at?
Not this year. It's just predominantly going to be the next show this year. I will do some regional events, and I will travel to those that are requested me
Okay.
to be.
Well, be on the lookout for Chris if you're going to a petroleum convention. Chris, thank you so much. That was super informative. I really appreciate your time and effort. And yeah, thanks so much.
Thank you very much, and